Hello, and today I'm doing Newton's first law. An object in motion stays in motion, and an object at rest stays at rest unless acted upon by an outside force. So what that means is, let's see, I have this Hot Wheel car here. The thing is, I push this Hot Wheel car. The thing is, it stopped though. But Newton's law states that an object in motion stays in motion. But it also states that an object acted upon by a secondary or outside force changes its motion. So that would be the track. The track creates friction, which slows it down. So the car doesn't stay in motion. Or I set the car here. The thing is, the car won't move because the car has no energy to move. Unless I, let's say, push it, now it moves. Like that. Or it could not, just doesn't have to be pushed by us, and it can be pushed by machines like this. Well, that's a little excessive, but yeah, it shot it. So, an object in motion, say this car here. Then look, on this track, it glides a little, because the track is smooth. But if I try and roll it on this carpet, it doesn't roll that far, because the carpet makes more friction. So let's say I have, instead of this car, I get this very light one. Instead of it only going a few inches, it goes quite a bit further. I mean, not this one, but it would because it's made out of plastic and not metal. So look, if I take this car right here, which is made out of metal, put it right here and push it, it doesn't go that far. But if I take this car, and it goes all the way over here. And then I take this one, which is another metal car, start right here. This one went further. Well, that's because it's lighter and more aerodynamic than this one. So, since this one has plastic wheels and not metal wheels like this one does, cheaper plastic, and this one has actual wheels made for this. These wheels are very smooth, so they don't create much friction. But since this is more rough plastic, it creates more friction. In this car, say the fact that it has metal-ish wheels, it goes quite a bit further, except for there's a turn there that stops it. Now I have this Nerf gun right here, and when I pull back on this and load it, I shoot it. Thing is, the dart didn't go through the wall, and it came back to me. The reason this dart came back to me is because it was acted upon by a secondary outside force, which makes it come back because it hits the door, and the door uses the momentum and brings it or pushes it back towards the way it came. So look, if I shoot it sideways, it'll come back the other way because it's angled. And this right here, since I shoot it up, it'll come over my head. See, look. If I do it up right here, I do like that, it went over my head. And if I do it again at the door, it comes back to me.